Good day, guys. My name is Babatunde Oluwatosin Ademola. Now, in our last video, we proved that Riemann sum is bounded and its integral are also bounded. Now, we also want to prove for the Riemann stage sum and what Riemann integral. So let's have this remark. Let f be a function on AB that map to R, be bounded on AB. Now, this G, you understood from the definition of Riemann stage, which I gave the other time, that G is monotonic increasing on AB. Then both the lower and upper Riemann sum of f with respect to G are also bounded. Furthermore, both lower and upper Riemann stage integral of f are bounded. Now, look, let's have a proof. Since f is bounded on AB, abi, for something to be bounded, it must be within an interval. So there exist real numbers m and m such that m is less or equals to f less or equals to, you understand? It shows that it is what? Bounded. Now, if f is bounded on AB, abi, this implies that f is also bounded on its subinterval, abi, it's also bounded on the subinterval of AB, abi. Now this is the subinterval now, si minus 1 xi, abi, which is contained in what AB. Now, if f is bounded here, is also bounded here. Now there exists real number what? Mi and what? M. They are both in R, that is, they are real, such that Mi is less or equals to f less or equals to M. Now, from the assumption like this stuff now that I gave, let's have this number line. This is our M, the main boundary, that is, which f is bounded on. If you now have the sub-interval, this is representing the sub-interval. Is always within what? Our main interval. Now we can see that m is less or equals to what? Mi less or equals to what? Capital Mi less or equals to what? M. Now, introducing from here, now we have this introducing. This one is Riemann stage. So instead of, in our last video we introduced delta xi, but here in this case we are introducing delta xi, abi. So introducing, we have m delta gxi, abi, less or equals to mi delta gxi less or equals to mi delta gxi less or equals to m delta gxi. Now look at, also let's introduce sum. Introducing sum, that is summation I equals to 1 to n. Now if you introduce it over the inequality here, we are going to have, there's no I here, so we can write it as m summation I equals to 1 to n delta gxi, abi, less or equals to, now this one is having I, so it will be included. This is I equals to 1 to n mi delta gxi less or equals to, now you come into summation, abi, I equals to 1 to n, this is summation capital Mi delta g xi less or equals to, you know, there's no I here, so we can bring it out. Mi summation I equals to 1 to n delta g xi. Now look at this. Imagine we have this kind of number line now. Okay, let me draw a new one. We have our A to be here and our B to be here. We now have this one to be x1, x2, x3, x4, x5. Abi, we now have a function that is, which is our g of x now, is acting on this. You know, we are going to have g of x naught. Abi, you know, it's going to be a real number. It's going to be a real number, so it will be in this boundary. Let's give that one k naught. It's going to be a real number. This one will be g of x1, which is what, k1, up to when we get to g of xn, which is equals to what, kn. For example, this is an assumption. Now if you now looking for the distance between their two, like if you continue the distance, you know, indirectly what we are saying here is we are looking for the sum of what, when I is equals to 1 to n of what, delta g xi. Abi, because look at this, usually this one minus this one, that's the meaning of this. So adding them 1 1 1 1 1, you see, you still result back to what, b minus what, a, because this one will be equals to b minus a. Because once you subtract this, you have answer, subtract this, you have answer, subtract it, adding them is same to by saying b minus what, a straight. So here I'm going to say this is what, this. I hope you understood how this comes to this. Now this, from our definition, this is lower Riemann stage sum. So we know that LPFG is equals to what, summation I equals to 1 to n mi delta g of what, xi. Abi, also, and lastly we have UPFG to be equals to what, mi summation I equals to 1 to n mi delta g xi, right? Do you get it? Now putting, like, look at this, this very stuff from here, from this part. Now you know we are going to have m equal, then you know this is what, b minus what, b minus a, which is less or equals to, this is what, L, the lower sum. So this is UPFG. So, and this is less than what, MB minus A. Now we can see that both the upper and lower Riemann stage sum are bounded. Both the upper and lower Riemann stage sum are bounded. So you can try for the integral bounded. Thank you.